Okay, last talk of the conference. Try to stay awake. So hey all, I'm here to talk about world creation. No, not that one. And instead of 7 days, I only have 20 minutes, so hold on to your hats. So hi again, I'm Eetu Martola. As always, this is not just me, but a team effort. Ilkka is my partner in crime in this, and Laura and Rule have left their mark in the generator as well. All in all, the world team is 5 people, with 2 of us tech artists. The company is Mainframe. I guess we are an indie startup with 62-ish people, and that is not a lot for a full-scale MMO. One half of the company is in Finland, one half in Iceland, and one half is scattered all over. The game is called PAX Day. It's a medieval sandbox MMO with a large open world using Unreal 5.4 at the moment. And currently we are in early access. I have no time to talk about the game itself, but look it up somewhere, it's cool. So that you know what I'm talking about, here's what the world looks like at the moment. And some screenshots. And the players can also build in the world, but that's not the topic today, but it's really nice. So we need to create a very large world and a dense one with not many people, which means, to the great surprise of everyone here, that we need to go procedural. Or rather, procedurally assisted, as I like to say. Let's start with some philosophy. Firstly, we do not want to go full procedural. Fractals are boring when you look at them for more than 10 seconds. The world needs a human touch, but a computer needs to fill in the rest. This has been a guiding principle for us, how to get a human to make the important decisions and not have to make the boring decisions. On a very abstract level, for us, this means a world artist draws a map and the computer creates a 3D world out of it. A handmade world would be the prettiest, but that's just not realistic with our team. But the manpower question is only half of the reason to go procedural. The other half is about making large changes. And not just the ability to make large changes, but the low threshold of making changes. It's easy to be afraid of making changes because all the downstream cost and quality comes from how many changes you can make. By keeping the whole world generation live, it's easy and cheap for us to make even sweeping changes without fear. The world is generated from scratch each time. If we had done manual changes and fixes to the world, those would be lost and would need to be redone. Yeah, we literally could lose our Unreal levels and we would be fine. And for third, we are creating a realistic world, but it can't be just a scan of a real place. That would look good, but it wouldn't play good. The world is a servant to the game systems, and the game design rules over world design. And in effect, that means that, for example, our biome placement is not in any way natural. And then our world layout. The world is made of regions, and currently we have only one. This one's modeled roughly after southern France. A region is made of provinces with gates between them. Every province is 10 by 10 kilometers and is their own world partition root level in Unreal. And a province is further made of cells. Every 2 by 2 kilometer cell is an Unreal level that is level instanced to the province root level. So a root level is a 5 by 5 grid of level instances. And the basic layout of the pipeline. First, we have our carefully selected human inputs, then the actual generator, which results in a lot of outputs. And all this is governed by BRO, our build resource orchestrator. So let's dive in. So on the top of the pipeline are the human inputs. First, we have a crude sculpt of the whole world. It's really needed to make the world interesting and so that it makes sense. Like in the north, we have this mountainous region and then lowlands over there with some big lakes in between or something like that. There is very little detail in the sculpt. It's mostly just about the masses, so it's still cheap to make changes to it. Next up is the map making. We do not have the manpower to create our own world editor, and because we already want to work on the level of a 2D map, then why not use an actual map making software? So we are using QGIS as our world editor. And in this 2D map, we mark up the locations of all the sites in the world, the road connectivity, the lakes and such, as well as biome areas and server zones. And this data lives in a PostGIS database, which we can query from Houdini. And all the tabular data is in a bunch of sheets, stuff like which plants grow in which biomes, in which amounts, and so on. There's quite a few of these. And we have no user parameters in Houdini or in Unreal. Everything's in the sheets. And a quick pro tip, it's really easy to work with Google Sheets and Houdini. You can just share the Google Sheet as CSV and then make a, I guess it's one line change in the the Houdini table import SOP, so you can just read from Google Sheets. And yeah, the rest is then the generator. You all know Houdini and the Unreal plugin. The plugin is really meant for creating interactive tools for using inside the editor, but we use it to run an automated hands-off pipeline. The generator itself is one monolithic HDA and is run in Unreal separately for each world cell. So one instance of the tool in all of those sublevels. It knows where it is in the world and generates the 2 kilometers around itself. It owns that world cell. It's a nicely modularized system. One module does the lakes, one does the roads, and so on. And it wasn't always so nice. When working on a generator like this, it's really easy to want to have everything depend on everything else, and that gets really ugly really fast. It's a bit of that good old mad wizard syndrome that Houdini people easily get. Instead, we took a functional programming mindset. Each module can only use the data from its input. No references whatsoever are allowed. This way, it's also easy to just bypass a module. Looking inside an empty module, we have the inputs and the outputs, which are kind of the API of the modules. Different types of data flow in their own pipes, like landscapes, masks, instances, and so on. And each module adds its own stuff to these pipes as packed geometry. Any later module can then easily pick up the data packages it needs from these data pipes. And every data package also shows which module created it if you need to go back. And a very quick run through the main modules. At first, we do the large-scale processing, some neural networks, some lake finding, a bit of erosion, stuff like that. And this is done on the whole province level to ensure the continuity across the cell edges. Next up is settlements, basically all points of interest. These are all handmade level instances in Unreal. And each one also has a separate footprint geometry on disk, which is used to modify the landscape to snugly fit the level instance. We have 3 sorts of lakes, ones at sea level, at the bottom of the valleys, automatic ones from Gaia, and ones drawn on the map. The other 2 are quite easy to integrate to the landscape, but the drawn ones are not really usually in a physically correct location, so we have to do quite a bit of massaging of the surroundings. Bridges, they are modular and adapt to where they are put. And for small sites and encounters, we do not want to manually add them onto the map. That would be just too much. So they are generated randomly in clusters. They all have the same footprint, an empty 80-meter flat circle, so they can be freely instantiated to any prepared location. And with the same API, we can also have just empty sockets in the world like this, and where we can instantiate things at runtime. There is a module for smaller streams. We pick random points above a certain height and trace them down in the natural flow direction. If the stream we get that way is long enough and hits an existing water feature, we save it. We've had a little bit too many problems with these, so they are disabled at the moment, sadly. And roads. The map data only has connectivity info for the roads, which place is connected where, and the actual routes are generated. And if the sites have defined a road connector, they are automatically connected to the main roads. And here another pro tip. In Houdini, it's really easy and fast to do all your route finding in one go, in one SOP, but it's not always good to do it that way. If you do it in a loop, one by one, it's slower, but you can get much more natural road networks because any new road can connect to any one already generated road. And cliffs, like probably everyone knows, any vertical bits of a height field, they are always super boring. So we are instantiating bigger cliff pieces on them. And with clever use of the pieces, we are actually using only 4 different pieces at the moment, but they just work really fine. Scattering, there is, of course, a lot of trees, bushes, and debris scattered all over the world. There could be a lot to say about this, but getting it all to look good is more an art than a science, so just keep on tweaking. And more about biome tiles in a bit. The rest of the generator is really about creating all the different outputs we need. There's, of course, all the visual 3D stuff you see in the world, which is mostly lots and lots of instancing. And it's quite curious, we really create very little new geometry. It's only the road surfaces that are actual new geometry. But there's a lot more than just the visual outputs. An MMO needs a lot of background data of all sorts, so we write out all kinds of textures and masks and JSONs for use by game systems. Just the resource system alone could be a talk of its own. Oh, and a pro tip about masks. Instead of, for example, a road mask, we don't have a binary, this is a road and this is not road, but we use 2D distance fields for everything. So a pixel says that this is the distance to the nearest road. It's when you need to use the mask somewhere, it's a much more flexible way. And by itself, the generator, the HDA, just generates its one cell within its own level, and something needs to take care of the overall process. And for that, we have Bro. It's a Python overseer for the whole build process. At its core, it loads levels, empties them out, sets options and cooks the HDA, runs all sorts of post processes, and then saves the levels. And each level is its own job, which is sent to the Houdini's own HQ farm controller. And Bro also handles all the perforce traffic. So we push a button in Bro, wait a few hours, and we have a new world in Unreal. It's great. And after that, quick run through a couple of juicy bits. Much of the generator is really quite standard stuff, but I thought I'd highlight a couple of systems. Funnily enough, our biome tiles are actually quite close to what we saw in the prologue talk yesterday. So yes, biome tiles. So think of the scale spectrum of game worlds. It's the large forms are handled by the landscape geometry, like in the scale of dozen meters and up. And the small scale stuff, like below 1 meter and below, it's handled by textures, grass, and random small scattered bits. And that usually leaves a hole in the scatter or the scale spectrum for stuff of like a few meters in scale. Just randomly scattering stuff of this size makes things too random and cluttered, but you can't handcraft it all either, at least we can't. For this, we have biome tiles. The idea is to handcraft a library of hexagonal tiles with hand-placed meshes on top of height geometry. The world is then divided into a hex grid, and a random tile from the library is placed at each hex with a random rotation. And this is done according to the biomes, so that each biome only uses a given set of tiles. The biome tile height is used to modify the existing landscape, and all the meshes are placed at their modified heights. And we also support dropping meshes using physics here. This nicely satisfies the goal of having human-designed, natural-feeling features in the world, but so that they adapt to their surroundings. In theory, this introduces some repetition, but because of the variation in the base landscape and getting mixed up with the other scatter systems, you don't really feel the repetition. We also randomly delete bits from each tile. And this is really the space between manual and procedural that we really like. And linear biome tiles are same-ish, but for lines instead of areas. We handcraft, say, 500 meters of roadside, 500 meters of lakeside, and so on, to form a library of strips. On the other hand, we need the linear features in the world we want to use these strips for. These are mostly automatically derived features, such as lakesides and roadsides, but we can also draw these straight on the map in QGIS. If you want to add an old wall going through the world or something. These can also be a bit more granular. For example, we have a road next to cliff as a separate type, so we can put some guardrails there. The way it works, we copy random sections from all applicable library strips and deform the result along our linear landscape features. This way we get details of this sort, again, in the middle of handcrafted and procedural. We also needed a way to get from our rough sculpt to a detailed terrain. And that needs more than just your basic erosion. At first we used Gaia version 1, but it was surprisingly hard to work with. So we wanted to check neural networks. We ended up using Electronic Arts GAIDA system. We downloaded lots and lots of public domain height data and got it trained to work just well enough for us. And this is not your modern generative AI, but old school GANs. And this is from 2019, and it's getting a bit long in the tooth, so we are moving into our own system, but it's not quite there yet. And problems, it's always nice to hear about people's problems. So world partition, it's all in all, it's a great system, but it's been an endless source of trouble. Now with 5.4, it's finally starting to really work as it should. And 1 file per actor, it's great if you're working by hand, but for a pipeline, it's just an added inconvenience. And Unreal's grass system, it's a good example of things that work really nicely when you're working by hand, but getting it to update properly when scripted, it has been a headache for years. A more fundamental problem is the generator in Houdini can't see the Unreal assets, especially level instances. It just doesn't know what's in them. Sometimes we have additional geometry for that, like the site footprints we had, and sometimes we create a geo library on disk for Houdini, like for the Biome tiles. And the engine plugin, it's an asynchronous process, which is, it's great for interactive use, but it just makes things harder for us. We can't just wait for the generation to finish in Unreal. And the bake times are a bit high. It's at the moment we are on many cells. It's over 20 minutes, of which maybe 5 to 7 minutes are spent in Houdini, and the rest is spent on getting all the data from Unreal, like from Houdini to Unreal. And this extra 15 minutes is getting quite annoying. And especially when running live, it's important to be able to recreate an existing world. And with a generator, it's a bit of a chaos theory problem. When something changes in the beginning of the process, the end result can be very different. It's kind of the old butterfly thing. You can mitigate it if you keep this in mind, but it's a real problem with the generative approach. And running a live game is very different from developing a new game from scratch. For this development phase we are in, the pure generator approach has been awesome. But for running a live game, we would actually maybe need something more like an editor. So we might have to ditch the live generation principle at some point after we launch the game. It's sad. So what do we have? It's the 25-minute-ish generation time. It's okay-ish. And you can easily bypass modules when you're iterating on something. Or you can just iterate in Houdini so when it's very fast. The main thing is you can create the whole world overnight. That's like the pain point, so it's okay. And a non-technical artist can rebuild a cell when iterating without touching Houdini, which is also nice. And most important of all, we are still making big changes to the world with no fear. So all in all, I will claim it a success. It's not Red Dead Redemption, but for a 5-person world team, we are quite happy. And that's where I leave you. Thank you.
Thank you for the presentation. It was very cool. How do you handle players transferring from province to province? Because you said there were only set entry points through certain, like if you want to go from one province to another. How is that handled in the engine?
Yeah, there's, it's really quite simple. It's the edges of the provinces are like mountain area, and there's like natural thin places where we put gates where you walk into, and then Unreal, it's basically a loading screen. The gate, you load a new route level and you spawn on the other side of the gate on the other province. It's okay. Actually, we have some cool tech around that. Like within the province, it's also divided into many Unreal servers. So when you walk around in the world, you're actually being handed over from one Unreal server to another. So that's how we can handle large, like MMO kind of player counts, and that's where we have some of our own cool tech around that. So when there's a lot of player buildings, it's not seamless, but for areas where there's no buildings, maybe you can't even notice it when you're changing servers.
Hi, I'm over here.
Hi.
How do you deal with potential issues with seams across the cells that are being processed, because they're processed separately, like for roads and streams and stuff like that?
Yeah, that has been a big problem. It's for almost everything, we just disallow anything passing across the borders. So we kind of error out, and we have to move anything away if it tries to cross the level border. And we, just to be sure, we fade out almost after each module, we fade out all the effects from that module from the edge, so that the edge stays pristine.
So you have no really long roads. They're always kind of
the roads are a problem because they have to pass it. We usually just try to get them to pass on level areas of the world.
All right, thank you.
Hiya, you might have answered this one, but I don't know if I caught it. For your POI placements, is that done in your hand-painted map stage, or do you have rules that dictate where they can go within the Houdini process?
Yeah,
for like settlements,
any of the bigger
human bits.
Bigger POIs, they are marked on the map. So it's like a human decision that this kind of like a castle ruin or something goes into this place, and then we use of course we don't know what the actual level instance is like in Houdini, but we have those footprint geometry on disk, which we use to modify the environment so that it fits.
For your larger settlements, do they have to go on flat areas, or have you found a way to put them on more geometry?
We can put them anywhere. Sometimes they can be hard to reach if you put them in stupid places, but the system can handle anything.
Thank you.
So when Unreal updates to a new version, how much does that mess up your pipeline?
Oh, yeah. It has depended on the version. We quite often upgrade, but sometimes it takes a week or two, and sometimes it takes a month or two.
Are they aware of what you're doing? Do they work closely? Because you guys have quite an intricate pipeline. It must be
yeah,
interesting.
We are talking with them. Yeah, we are one of the. I guess we are one of the bigger like world partition users at the moment. But it depends on what changes in the engine.
Thank you. I think that was the last question. Thank you very much for an amazing talk.
Yeah, thank you.